Alright, welcome back. This will be Breakout Lab 7. Today we're going to be looking at functions and specifically passing variables by value and reference. I'm going to start out, we haven't done it in a while, but just to keep things fresh. There haven't been any changes, but just to keep up the habit, I'm going to go into my FGCUGL folder here, which is also a Git repository. And here I can launch git bash and then just do a git pull. And it should tell me that I'm up to date. If for some reason I wasn't, I would see the changes that it brought down. So, all right, so let's get ready. I'm going to start a new project in Visual Studio, and this will be, let's see, create a new project. And this will be a breakout project. And I'll call this Breakout 7. I don't remember how I've been naming them. And let me make sure it's going to my documents repos. All right. I've got my basic, and we're going to make changes to the template, so I'll probably show that both here in Visual Studio and in the Linux version if you're running on Macs or just doing the Linux version, just to refresh how to set your base template again. But let's start with what's in our base template. Of course, we have our breakout header and source file, which is what we're writing. We have our FGCUGLH, and we won't make changes to those. If we have changes in those, we pull them down through the Git repository. So I'm going to close those, but you can always reference those to see the functions that we're using from them. All right, so to get started, these are a blank template, and we're going to kind of continue parts of Lab 6. So I don't want to open Lab and paint all that code into here, but I do want to have it open in, say, a text editor. So I'm going to navigate out to my documents, repos, and down here to Breakout 6. And then I just want to open my two files in a text editor. So I'll just open them in Notepad++. So I've got the header file and the breakout file. Now, one change that I'll be putting this out in class, but I want you guys to add a new element up here. And you guys don't have to do this. I'm just OCD, so I'm going to do this. But after the file name, we're going to add a new element, lab, and this will be lab 7. And you'll need to update that every time you create your files. And I'll get on you without taking points away to start with, but then I'll start taking points off if you're not doing it. But it'll help with identifying which set of files we're looking at. All right, so this will be my Lab 7 header file, and this will be my Lab 7 source file, or implementation file as we call it. All right, let's start with some of our constants from Lab 6, because some of these constants now are going to live on with us going forward. So in my Lab 6 header file, which notice we didn't have the lab element at that time, we have our window height and title, so we want to keep those. We had this sleep interval. We're going to bring that in for now. That'll be changing. And then the rest of these elements here, the game components with the ball properties, let's copy those. And they're going to start to become a permanent part of our template. Like I said, we'll be changing this element in this lab, but for right now, we'll leave it there. But I had a sleep interval of like 500 million, I think, and the speed for my ball in the horizontal and the vertical axis. All right, coming over here to our breakout file, to our implementation file from our implementation from Lab 6. We want to set the starting location of the ball. Now this will change eventually, but for right now that's good. And we need this game over, and we're going to be doing this game over. I'll just type that, but I'm going to copy this code and come over here, and it goes in between where we create the window and start the game loop. And I'm actually going to move this variable. I'm going to put it down here under the comment because it's really tightly connected to this while loop. And then I'm going to get rid of this line and change this back to the not game over. And we'll be saving the template this way, so we won't have to do this next time. And then just down here at the end of the loop, go back here. We had this code down here at the end of here's the end of the game loop. And we had this sleep. I'm going to copy from the sleep down here to that where we set game over equal to game over or window closing. So we'll be overriding the get events, which is right here. So I'm going to highlight that and paste. And then we're going to be getting rid of this part in this lab. We'll be changing the way that works. If we look at the article I pointed us to earlier on about game programming, our main game loop should look something like this. Now we have the while true, we have the while not game over. So what we need are these three methods. And so that's what we're going to be developing in this lab. So if we were actually just to copy this, and you don't have to, you'll be able to type. I'm going to shrink this down. Here is our paint method. I don't want to mess with that yet. Here's our while not game over. So I'm going to come down in here, and I'm just going to paint these, but I'm going to change them into comments. So, and I won't even make them look like functions. But this is going to govern what we want to do and where. And so the first of all, our window paint is part of the rendering. And so we'll be moving that into here. Now let's look back at our lab 6 and start pulling out the pieces that represent each of these. Here's our process input. And we're going to see this looks like processing input, but this is really part of the updating. But for processing input, we just need to get the input from the user. So we're going to copy this, and I'm just going to copy this part of it from lab 6, and I'm going to paste that here, and that will be our process input for now. All right, we'll be changing that in a later lab. All right, now we need to do the update. But if we look back at our game loop theory, well, let's not worry about that yet. Let's just get our update in here. So let's start with, we want an update function. And if we look at our code first though, what are the things we need to update? We need to be able to update our, well, we need to be able to reference our ball speed, X and Y. And we need our ball velocity, and that's actually what we're updating. Notice that's on the left side of an assignment operator, and these are global constants, so we're not updating those, but we are updating our ball velocities, and here we're updating our ball X and Y, and then of course here we're drawing. So that's obviously part of our render. So we basically need this code. All right, so before we go cutting and pasting though, let's come down here below main, because we define our functions below main, and we needed an update method. So we're going to start with our funky comment that gives us our context sensitive help. All right, and I'm just going to space in one, and I'm going to say update game objects. That'll be my short description, and we're going to have parameters and a return. And all right, and then we're going to build our update method. So our update method is going to return a Boolean, and I'm going to tab over twice. I think that'll be enough space. If not, I'll make more later, but I'm going to say we're going to return true if game should end. All right, so we'll know from our update method if the game should end, which for us would be somebody, the ball went past the paddle, or if the person, chose to quit, and we'll know that from the key. All right, so parameters. Well, we're going to need user input, the key. So, which when I say the key, I mean we're passing in this keyboard input. All right, now eventually that's going to be the directional information for the player's paddle. Right now it's the ball, so I'm going to leave that one off at the end. So I'm going to start with these key ones here. Matter of fact, I'm going to start with the ball X and Y. They kind of represent the ball and then the ball's velocities. So, and you can actually do some copy and paste. We're going to have ball X and ball Y. And then we're going to have ball velocity X and ball velocity Y. Right, and I'm going to go ahead and create some extra space in here just to make this really stand out. Remember, I said in classes you can compress, you can even do things like tab this stuff in more, so that you can see that the parameters are under that parameter label. You can do uppercasing if you want. Don't get too crazy with it, but you want things to somewhat stand out. All right, so let's, so we are going to need to go a little bit more over if we want to line things up, which just makes it look nice, easier to read. All right, so this is the horizontal coordinate of the ball. And watch this, we'll copy and paste. And this is the vertical coordinate of the ball. And then this is the horizontal speed of the ball and the vertical speed. Remember, these comments are for yourself later on or somebody else. When you roll over a function call, you can see this comment block. All right, so let me just, oh, that was tur. We'll make it true. And then we need direction. And that's going to be keyboard input direction. All right, notice that's our key variable, but we're going to slightly change its name in this function. All right, so now that we have an idea of what we want to build, we can start to actually define the function. So one, we start with our return type, sorry, our bool, and then our name. This will be update, and then we need our parameter list, right? And then we're going to need the body, right? And then within the body, because we have a data type, we should go ahead and create a variable, right? And the variable should be based off this description, true if the game should end. Well, let's not do end because that's usually a keyword, but let's do quit. And we don't want the game to end, so initially we would think we would want this to be false, and then we'll just set it to true if we get to a condition where the game should end, right? And then we want to return quit, right? So we do this first before trying to fill in any of the guts so that we get our function set up really well. All right, now we need these variables, all right? And you can do some copy and paste. If we look up here, we have them defined here. We're talking basically about that portion, right? Notice I've kept these named the same, which is fine. And I can then paste, and I'm just going to do a comma and paste again and change that to a Y. And then I'm going to come up here and copy this. And I do this because, as you guys know, I'm a terrible speller and I misspell the same words over and over again, so copy and paste is your friend. There's my ball velocity X and my ball velocity Y. And then it says we need direction, right? And we know this is going to be the keyboard input that we're getting here, so it's a char. So I'm going to do a char, and I'm going to call it direction. All right. So let's go to our Lab 6 code, and we can now copy all of this. So this switch statement and the adjusting of the balls X and Y. So I'm going to copy that from Lab 6, and I'm going to paste that right here. Now, notice we don't have key, so that's now direction. And then we don't have game over, it's called quit. And we could have called the variable in here game over, that's fine. What I'm trying to show you guys is that a lot of times the variables in the parameters in your function will be named slightly different than the variables that you pass to them as arguments. All right, so that's good for our update. Remember, this is the definition. We still have to declare this function above main. So let's copy our definition statement, and let's come up here above main, and we'll do function photo types, and we're going to paste that in here, and then we just add a semicolon. Now, because we said that we actually want to modify, and I'll be demonstrating this in our lectures, but because we want to modify the ball's velocities and the ball's location, we need to pass these variables by reference. So we're going to add the reference operator onto each of these variables to say they're being passed by reference. And I have to remember to do that up here in the declaration statement. All right, so after that, all we have is this paint. Let's just go ahead and add the call-in. That way that piece is done. So we're going to be calling this function, right? Now, one thing you can do is you can actually copy the function prototype and paste it in here, and then just replace the pieces. This bool is actually going to be game over with an assignment operator, because remember, the function returns to the left into something. So in this case, an assignment into our variable game over. And then we have to get rid of all of the data types from the declaration, because we now pass variables as arguments. All right, so, and we pass local variables as arguments. So these are our local variables to main, and we're passing them in. They just happen to be the same name, but this one is not, right? This one is this local variable key. And all we care about is that it is a char data type. Right, so char data type, our direction keyboard input. So we're just going to make that key. All right, so now we've got that. So now let's focus on the render function. All right, so if we look at Lab 6 real quick, here are the variables that we need to draw the circle. We need the X and the Y, and we need the ball size and the ball color, but those are global constants, so we don't have to pass those, just like we didn't have to pass ball X speeds, ball speeds to the update. So we right now just need ball X and ball Y. All right, so let's, for our render method, we're going to come down below the update because we want to keep things in a logical order. And we update the game first, so I need 3 asterisks. All right, and then this is going to be draw game objects on the open GL window. Okay, so we need parameters and returns. All right, now this is not going to have a return. I can document that. I can just say it's void. All right, and then for parameters right now, watch this. We just said we needed the ball X and ball Y. So I'm going to copy those from that definition, and I'm going to paste it here. Okay, and then now I can start to define the render method. It's void render. All right, I'm not going to worry about the parameters yet. I want to get a good function structure first. It doesn't return anything, so I don't need a return statement. All right, now I can go back. And we said the ball X and ball Y. Now, notice we do not modify it by drawing it. There's no change to it. So we don't need to pass them by reference. But I can still copy and paste this because I'm lazy, and programmers by default are usually lazy. So we do a lot of copy and paste. Right, and then I just get rid of this. Now notice it moved those, and that's fine. Visual Studio reformatted things for me. How about that? When I pasted it pasted it on the data type, which is a methodology. But anyway, we don't need the decorator for the operator for pass by reference here. Okay. So now we can come back over here to our Lab 6 code, and we're just doing the draw here and the paint. We just need those two. And we can paste those right here. All right, notice they kind of slightly gray out to say, okay, yeah, I found where I'm referencing that from. All right, and of course these are global constants. All right. And then now we didn't have a return. Remember, I forgot I like to put the ends here. So we know this is the end of render, because this will get bigger, and this was the end of update. And if I scroll up to the top of that, I should see end main, so I know that's what's above this. All right, and then if I come back up in here now, I don't need this paint. I can get rid of it. And now we need to declare our render method. We defined it down here, but now we need to declare it. So we copy the definition statement. We come up to our function prototypes, and we want to keep this in the same order we're defining them below. And I put a semicolon. Now it's declared. Right? And remember, we're not modifying them, so we're not passing them by reference, we're passing them by value. And then I come in here, and now I paste it again because I need to call it. I just don't need the data types. All right, so We're in our game loop, we're processing input, we're updating our game objects, we're rendering them on the screen, and then we're sleeping. Oh, I've got a semicolon there. And then we're going to sleep, checking for events, and updating our game over in case the events are causing it to close. And then that's the end of our game loop when we go around and do it again. So let's build. All right, and all these warnings are okay. And let's go ahead and run and make sure this is still running. Okay, it appears to still be running. Okay, I hit the X key to exit, and I'm going to stop the debugger. I just want to run it one more time. It should run fast because it's not building. And let's notice how choppy it is. You can kind of tell, especially when it's moving slow, you can tell how choppy the drawing is. And that's that sleep method that we're using. So we're going to add in some better timing now so that we see a much smoother drawing of the ball. All right, so we're going to introduce some new elements and remove the sleep loop here, and then we'll save the template. So the first thing we're going to do is we need to do some timing. So we need some new variables that we can use to track game timing. Basically, we're going to be tracking how long each processing of this loop takes. And so let's get some of the elements in, and then we'll talk about them briefly, which you'll need to read the article and attend the lectures to get more detail on them. But we're going to come in here right in between where we're setting up our ball and the starting of the game loop. And that's because this timing is really for the game loop. So we want these tightly coupled with this. We want some high precision timing. So instead of float, we're going to use the larger precision double. So we need some new variables, and we're going to do a type double. And remember, we did floats for our locations because we don't really need great precision. We just need a few decimal points, and we'll see why we're even worrying about decimal points here in a minute. But let me do a comment here. We are going to do timing for our game loop. All right, and we just need 3 variables really to track the timing. We need a start time for each game loop. And we can go ahead and initialize that right now using our FGCUGL library. So we use the namespace, and we want to get, there it is, get time. We want to get time. All right, and then we need 2 other variables right now. We need a finish time so that we know when the game loop ended. And we can just initialize that right now to 0. And remember that, oops, never can spell double right. We want to initialize it with a floating point literal. And then we can just go ahead and create, we're going to have another variable called our delta time. And oops, and we're going to set that equal to 0.0 to start with. All right, so real briefly, let's talk about this. I'll talk about it in more detail in the class. Using this game loop theory, we can see this is what we currently have now. We process input, update the game render, and then sleep. We don't want to sleep anymore. We want to go to, and I'm just jumping through this so we can see it real quick. You can kind of see in here where we're going. We'll have our current time, elapsed time, and then lag, and that's what we're going to call our delta time, is lag. All right, and so basically we're going to do this. We're going to process input, and then we're going to update the game on frame boundaries, and we'll see what the frame boundaries are, and then we'll render. So a lot of times we'll just process, we'll skip the update and render, process input, skip the update and render, and then we'll hit a frame boundary and we'll go in and update the game. And so it's going to look something like this. We're going to be running along, and we're going to update and render, update, update and render. And really it's going to be the other way around. We're going to be rendering a lot and then only updating periodically. And we'll see that. And so what will end up happening, and like I said, I won't go into it in great detail here, is we're going to put, okay, let's just get it in here and then I can explain it a little better. We're going to do the timing portion right here, and we're going to start by, we've started the timer for this loop right here. So now we need to stop it. So we want to get finish time. And we're going to just set that equal to that same function, fgcugl get time. All right, so we'll know this is the end of the previous loop. All right. Now, for the very first loop, it will be the difference in time between setting the time here and getting to this line. So our very first time entering the loop, we're going to have a very, very short time. All right. Our delta time, or our lag, we're always going to add to it. So it's going to build up lag. And let me just get it in here. It will be our finish time, because that should be greater, minus our start time. Start time. All right. And so let's start getting some good commenting in here. Stop the, what did I want to call it? Stop, stop frame time, frame timer, and then add current lag, and then let's do our start time equals our finish time. All right, and that way what we're saying is we stop the timer here, so we know what time this last iteration stopped, so we'll make that the new start time. All right, then we'll go through process input, update the game, render it, come back around and stop that, and then now our delta time will represent our last finish time and our new finish, you know, the difference between those two. And so what we'll see is, and it's hard to really see it because of how fast this thing processes, but this will be fractional seconds. Like, actually it'll be fractional milliseconds. So some of these loops it'll be down in the nanoseconds, but we'll keep adding up those small fractions till we eventually hit a frame boundary. All right, so now all we need is our frame boundary, and we're going to do that in our header file. Let me save. We're going to come here to our header file, and instead of this sleep interval now, we're going to have a more important variable. We're going to have, and I'm going to do it here as a constant double, and we're going to call it frame rate. All right, and we're going to make that equal to 1.0 divided by 60.0. And basically what we're setting up is a 60 frames per second rate. All right, and I'm going to get rid of this sleep interval. All right, so what we're doing is we're going to take 1 second and we're going to break it up into 60 slices. And so what we want to do is we want to update our game every 60th of a second, which we'd find is like, it's actually showing us the result right there. It's 0.01666666. So every 0.016666 seconds, we should do an update. And if we do that every 0.01666 seconds, then every second we will have done 60 updates to our game. All right. So we're going to do that around our update. So we're going to come in here and we are going to do if delta, or I'm sorry, not if, it's going to be a while loop. While our delta time is greater than or equal to our new frame rate, then we'll update the game. Right? And because this is now our control variable, we must update the control variable. So eventually we want this to not be greater than frame rate. So we'll just subtract. We can subtract our frame rate. All right, so, and then now we can get rid of this whole sleep thing down here. All right, we're almost done. So just to read through this here, we will calculate the current amount of time, of fractional time it took for the last full game loop, and we'll add that to our delta time. And then we'll process input. If we've made it to a frame, 0.016, which remember I said most of these will be really, really small fractional values for the amount of time each loop takes. So we'll have to build up a bunch of them before we actually get our delta time greater than 0.016, but that will tell us that we've gone a full frame, and so now we'll move the ball. All right. Otherwise, we'll just keep rendering the ball in whatever its last location was every loop until we build up to a frame, and then we'll render it. All right. So let's test this out. All we've done is gotten rid of the sleep. I'm going to build. All right, let's run it. Whoa, it went super fast. So the reason it went so fast is now we only want in our update, we only want to update the ball by the fractional amount it moved. In other words, this velocity, we need to just do, this velocity is how fast we wanted the ball to move per second. But now we're moving the ball only 1/60th of that velocity each time we do an update, right? And the reason we're doing this delta time greater than or equal to frame rate is just in case something lags our game in between this portion of the loop and this portion of the loop. There is a slight chance that we've built up 2 frames of lag before we got to this check here. If that's the case, we actually needed to do 2 updates to catch the ball up to, in other words, move the ball by 2 frames to catch up. And then each time we move it, of course, we'll be subtracting frame rate. But to get that, what is that fraction that we want to move the ball? We want to pass our delta time into this function. So I'm just going to put that here, delta time, and then we need to define it because it's not here. So I'm going to come down to the definition, and here, just for fun, I'm going to call this, now this is a double, and I'm going to call it lag, just to be different. All right. And then I won't update it in here because I updated inside that loop, right? So I'm passing that to lag. I need to come up here to my declaration statement and add it here. So that was a double lag. All right, and now coming back down to update, I want to modify that velocity by my lag. So if it's 0.016, I will do 0.016 times the velocity and add that to the ball's location. Oh, now we got a much smoother ball. All right, now notice we have still a lot of flickering going on. All right. The reason why is, for most of the frames, we're just rendering it in the exact same spot. And then when we hit a frame boundary, we move it. So the ball literally jumps a full frame every time, which is 1/60th of a second. So it's not very much, but it's still enough to cause some flickering. All right, so let's fix some of that. The way we're going to do that is we're also going to pass our lag into our render method. All right, so, but we also need to pass our velocities. All right, so I'll explain this more in the lecture, but I just want to copy these and I'm going to add them to the render method. Now the render method still will not modify, oops, I had an extra comma there. It's not going to modify them in here. All right, we won't ever see these on the left side of an assignment in here. All right, but we need to come up with a different value for these ball X and ball Y. Using that, we're going to use the exact same formula that we have here, but we don't want to modify ball X and ball Y. And in reality, we're not modifying them because we're not passing them by reference, we're passing them by value. So we change them here, but that change won't get passed back because we're not passing these by reference. But we're using the exact same formula. So we are going to draw the ball in the new position relative to current lag. All right, and that way we need to add these. Let me catch these because we need to add them. We need to add them up in our declaration statement. And then I'll come back down and explain one last thing. We're almost done. And then in our call to render. And then of course we don't want the data types there. And we didn't call this lag, we called it delta time. The local variable is called delta time. All right. All right, so let's look at this real quick. Here's our game loop. All right, while not game over, stop the timer for the last loop, calculate the amount of time between it when it started and when it finished, add that to delta, and then start a new timer by just copying the finish time into start time. Process, get any keyboard input. If we've reached a 1/60th of a frame boundary or more, go ahead and update the ball's location relative to that many updates and subtract the frame rate from that. If we've gone 2, we'll come around and do it again. All right, then come down, render the ball in the new location relative to the current lag. In other words, go ahead and show any fractional frames or fractional speed that it's moved. In other words, 2 pixels per second. All right, so it may have moved 1 pixel. Remember, it will have to go 30 frames before it's moved 1 pixel, because we're going to be drawing 60 frames a second and we wanted to go 2 pixels per second. So we'd have to go 30, half of our frames would be 1 pixel. So when we get to 30 updates, because most of our updates are going to be fractional pixels, that would be truncated when we go to draw, because our draw method is really going to convert that to integer, pixels, because we don't have fractional pixels on our screen. All right, so let's see this work. All right, so we've just gotten rid of a little bit of the flickering. All right, it's still not a super heavy graphics system that we've got set up here, but we've got a nice smooth ball moving at a nice rate. We don't have all that chunkiness anymore, and we've gotten rid of some of the rendering flickering. There's still some there, but that's just the type of drawing that we're doing. All right, So one last thing, let's save this now as our new template because we will now be basing all of our future labs all off this code. So all we have to do that is under project, now we're going to export, oh, I clicked on build project. We're going to export a template. We're going to export a project template using this project that we're in, Breakout 7. And the template's name is going to be Breakout. And this is going to be our OpenGL breakout game. Right? We're going to store it in my exported templates breakout.zip. So it's going to overwrite the existing one. Automatically import, display. We don't need to, but I'll let it display. And then click finish. It's going to say, do I want to overwrite the one? Yes. All right. And it just opened it so I can see it. Right? If I go into it, I can see the files that it's going to import when I create a new project now based off my breakout. It shouldn't have been called that. That's okay. That's no big deal. I think it renames them anyway based off the new project. Okay, so that's it for this lab. If I close this solution, and just to test it out, if I was to create a new project, and I do it from Breakout, and I call it, I'm just going to do Breakout temp in my document. And now actually I'm going to move this one because I'm just showing, I'm going to put it in my source repos and do create. I just want to show that I get all of my updated files. So if I go into my Breakout header file, I now have my new frame rate. Everything else stayed the same. And if I go into my Breakout CPP, I now have my update and render method and all my new code, and I can start my next lab from this code now. All right, so that was it for Breakout 7. I hope you are following along and enjoying this.